Welcome to a lesson on transforming your data to achieve linearity. We've got the number of motor vehicles registered in the U.S. has grown as follows, and we got a list from 1940 to 1985, and we're going to go ahead and plot the number of vehicles against time, and what kind of growth does this exhibit. Alright, I've used the TI Inspire to go ahead and plot the data, and remember that year explains vehicle, so year was my explanatory, and the vehicle is my response variable, hence the year goes on the x-axis and the vehicle goes on the y-axis. And when we take a look at our scatter plot, it kind of looks, it's not too bad as far as, well, I pick 2 points, kind of looks like it could be exponential. So what we should do at this point is, if we're not too sure, is let's go ahead and run some linear regression tests and check out our coefficient of determination, R squared, and our correlation, and see if we can get a more linear relationship between the two variables. So what I did here is, in here just a little refresher, when we make a scatter plot, we use the TI Inspire. We go to a list and spreadsheet, and we put in the A, we put in our explanatory variable, and our response variable goes in the next column. And then we go ahead from there, is we insert a data and statistic page, and that's, remember, on the TI Inspire, that is Control I. And from Control I, we hit data and statistics, and then that's when we can go ahead and create our scatter plot. Okay, so that's a little review on making a scatter plot on the TI Inspire. Once we've got the scatter plot and we're kind of taking a look at the relationship between our two variables, we'll want to go ahead and run some linear regression analysis on our data in the form of A plus BX. And when I did that, this here is right here. That is my my two variables. I have not manipulated yet by taking the log of the response variable and plotting it against the explanatory variable. And I see that my R is 98 and some change, and my R squared, my coefficient of determination, is 97. So I'm going to go ahead and see if I can get this even more linear. And how do we do that? We're going to use logs to transform the data into a linear association and then plot that transformed data. Okay, now I have used a TI Inspire to use logs to transform the data. And what I got is, I first just took the log of the vehicle. The way we do this in the TI Inspire is we go back to our spreadsheet, and in column C, I hope you can see this, I had made it kind of small. We go ahead and put log vehicle in that top cell, and then this is our the gray one we haven't used yet. That second cell is actually where the equation goes, and in that gray cell right here, you want to put in your TI Inspire. Alright, I have used the Inspire to plot the log vehicles versus the year. And just to give you an idea how to do that without actually taking the log of each individual vehicle on your own, we can have the Inspire do it for us. And the way we do that is right here in column C, we put log vehicle. And then this is, now we're going to start using this gray cell right here. We haven't used it in the past. And that is where the equation goes. So when you pop into that, and it'll say equals, and then you just put in log, and then vehicle. And it'll calculate all the logs of the vehicles for you, as it did below. You're going to notice that there's an empty space right here where 1945 was. And that's where we come to clearly the point 1945, comma 1.49 is an outlier. Can you suggest an explanation? If we go up here, back to this plot, that point right there is the only one that kind of dips below our initial point at 1940. Why could that be? Well, cars are made of metal, and back in 1945, World War II was going on, and what they did is they took all our resources, especially metal, and they used all those for military. So that could be a really good explanation why the number of cars dipped in that particular year, is because, again, they were putting all our resources, such as metal, into making weapons for the war, tanks, artillery shells, everything that was made of metal. That was all being directed towards the military. So World War II caused there to be less vehicles made, and that was due to the shortage of metal that was needed to produce stuff for the war. All right, the next question asks us to delete the outlier, x equals 1945, and use the remaining points to find the least square regression line. Equation of log y on x. Write the equation below and draw this line on your second linear graph. Well, I've already had the calculator draw the line for me. And the equation's right here. So we can predict the log of y. And we got our y-intercept of negative 30.2465 plus 0.016382x. And that is our least square regression line equation. And then determine the exponential equation model for the original data set. Form is y equals c times 10 to the kx. So the inverse transformation of a log to turn it into exponential. Gives a predicted value of y is equal to 10 to the power of negative 30.2406, our slope, times, I'll have to write that below, 10 to the 0.0164x. Sorry about that. I might have called that top one here slope. It's y-intercept, and this one's our slope. And that is how you do the inverse transformation of a log to write that exponential equation model for the original data set. Thank you for joining me on an example problem on how to transform our data to achieve linearity.